Hi, my name is Tara McGivern, and this is my submission for Alpha for multiplayer distributed programming. I'm working on this assignment with Fika Murta, and we are making a little game which is a 2D top-down shooter in space. So I'll do a quick run through the game of the game. The main objective is to collect as many stars as you can within a time limit. Of course, for the purpose of the screencast, I'm playing alone, but there would be other players in there, so they would be attempting to collect the stars at the same time, and whoever gets the most stars wins. So we'll just run this. So this project is is all based off the RoboCache project. And yeah, so I'm the pink ship flying about, and I have to collect these stars. So there are these platforms blocking my way. You can also use Xbox controller. I'll get into code about that, and in the top right hand corner is the time. The first thing I want to talk about though is the connection details. Okay, so this is based off what was used in the Shadow game. So you were able to input your name and IP into two respective text files, and the game would be able to read those rather than command line arguments. So for this, we do something very similar. We use a lot of the same code. It is adapted from Shadow after all, but one thing we do differently is we only require one text file. So I will just give you a quick glance at the text file in details. You've got the IP address and then the name. So take note here, the name, I've just repeated my name 4 times and included a load of underscores. So yeah, so we open that text file and then we make the assumption that on the first line is going to be the IP, and then on the second line is the client name. So we use getLine to read both of those lines and then store them in their respective variable names, or in respective variables. So we did adapt the names, so no underscores, just client IP and client name. And then another thing we do is, as I previously mentioned, to take note of my name, how it's quite long, is that I've restricted 16 characters. So in this file, it's about 19 characters, but when I run the game, you will notice that it has been cut down. So this prevents people inputting incredibly long names that take up the whole screen. So you'll notice here the last few letters have been cut off. Okay, so initially myself and Fikra wanted to make a side-scroller. So we started doing that by creating a platform, and these platforms would allow the player to jump on them, to climb up the screen, and down, and so on and so forth. But one thing we learned quite early on was this was very difficult to do. More so, it was hard to just integrate it with the collision code that was already there for RoboCache, based on RoboCache being a top-down game. And given the time limit, we opted to return to the top-down game. So we decided to still keep the platforms. You'll have seen them in the level there. They make it just a little bit more difficult for the player. They can't just fly across the screen. They have to dodge not only the other players but the platforms. So they're very similar to the mouse class in the sense that they have a position, but what makes them different is that when they come into contact with an instance of the cat class or little spaceship, they are pushed away and they do not die upon contact with the cat. Okay, so we also have gamepad functionality implemented. So in the input manager class on the client, we check or we set an instance of the controller to null pointer, and then if we check for the number or if any joysticks are connected, and if one is, we set that to the instance of the controller. Now I also looked into using the analog stick but was not fortunate with it for this submission, so that will be a feature for beta. Now we go down to the handle input class. We make the assumption that if you have the input or if you have the joystick connected, that you will be using that over the keyboard. So if the instance of your controller is set to or is not null pointer, then we will handle your gamepad input. So if you press B, you will shoot and you use your D-pad for movement. So up is forward, down is backwards, right is right, and left is left. And then here was also the experimental analog stick. Now if the instance of controller is null pointer, then it will just handle all input as though you were just using the keyboard. Okay, so another bit of persistency would be ensuring, so of course when you're playing you can see your score, so how many stars you've collected, but we would like to store that. So initially planned on writing to a text file, so we wanted our game to be timed, and one thing we noticed was that every time we set the server that it should not keep running. So up here to false, it does not end the game. So we decided to write to leaderboard.txt. Well, I decided to write to the leaderboard file.txt. So I'll showcase that now. So this was from an earlier test when I was running for just 12 seconds. So I hadn't killed anything by that point, but it puts my name and my score. So basically, after the allotted time for the game, we'd get all the scoreboard entries and then just write them to file to just give results, give an idea, add a bit more persistency to the game. Now at the moment this method has been called, what has actually been commented out, because I noticed, or I believe it is quite resource heavy, and whenever it was uncommented, it was hogging a lot of resources, and collision was turned off. I couldn't collide with any stars, I could phase through the platforms, and I couldn't shoot either. So that's just an attempt at persistency, though it does not function correctly. Okay, so one thing you'll notice is that the stars are moving about in the level, and they're not all moving in the same direction. They're actually drifting randomly. So on both the server and the client, we've added an update method that will tell the mouse to move with each frame. So initially when I was implementing this and I told the mice to move, they would be gone as soon as I ran the game, because I wasn't, or they were updating and moving too quickly since the game is 30 frames per second. So I get the delta time, which I divide 1 by 30 as we're using 30 frames, and then I pass this into the move method. So in the move method we get our forward vector. We use this to calculate our velocity, so we multiply the forward vector by 0.0001, so this is our direction, and then our delta time, which we've just calculated, 1 divided by 30, and then 200, so this is our linear speed. So our players are set to 50 on their max linear speed, but I found that this was too slow for the stars, so I set it to 200. And with regards to our direction, it's quite a small number, but I noticed any more, our stars would just disappear because they were moving too fast, or any slower, it was just too slow. Now, to create the kind of dynamic movement, so we don't know what direction each star is going in, we get the network ID of that star and we modulo it by 2, so we get the remainder of dividing it by 2. And if it's an even number, we're going to take kind of this branch of movement, and then if it's an odd number, we're going to send it in the opposite direction. So this makes kind of, initially when I was telling them to move, they're all flocking in one direction like a big pack of sheep, and this just makes it a bit more dynamic and a bit more interesting. We also give it a little bit of rotation, so they're not just going in straight lines, and kind of like the forward vector we're using for very small numbers, but we're keeping the same rotation as the player would have at 5. Okay, to add a bit of persistency to the game, we've adapted or based this class very heavily off Shadow's persistent player sprites. So basically, this class creates a file, a text file, and stores it in the assets folder and checks that every time the game is loaded for the player name and their preferred ID. So every ID has a corresponding color. So one thing I notice here is that when I play the game, my ship is always going to be pink. So this kind of creates a sense of familiarity for the player. It gives you a bit more of a in-game identity. So every time I load this, it's always going to be pink, provided I keep my player name consistent. So a little adjustment we've added to this is that if the file doesn't exist, we create it. So I'll just give you a quick preview of the file. So it's called persistence.txt and it's in the assets. So there's my player name, which has been shortened, and then 2, which is my preferred ID. So yeah, if the file is there, we will get the first line of that. So one thing I noticed in Shadow is that they were getting the first case of the colon being used, and I've changed that to the last on the off chance that our player has used that inner name. This will prevent any breaks or kind of errors. So we read the line and then we get our player name, because we know that will come up first, so that's from 0 to kind of the position of that colon, and then we'll get our player ID, which will then convert to an int, and then we'll store this in our map. So maps, allow us to store unique, in this case pairs, so we won't have my name appear 50 times because I've ran the game 50 times. It's only going to be there once. I have considered using a struct, which I may implement properly for beta. At the moment, because we only use a pair, it limits us in that we're only sending 2 pieces of data, but in the future we may want to send more in terms of saving the game. So this is an interesting possibility. So yeah, we insert that into our pair, and then we to get the ID, we take the player ID. So whether it was 11, 21, or 1, we module it by 9, and we'll always get 1. And this way, we know their preferred ID. And then that's if we have a new player, we'll throw that into our map. And then we also have functionality for searching for the player in that map. And of course it writes it all to a text file.